Okay, Steve, I'll turn it over to you.
Awesome. Thank you so much, Kathy. Good morning, everybody. My name's Stephen Hernandez. I will be hosting the winterizing and irrigation system session today. I just wanted to give you a little bit of background. I've been in the irrigation industry now for uh, going on 29 years. So I've been doing this a few minutes. I'm assuming that some of you may have had the experience of dealing with irrigation systems, or maybe you're brand new to it. But either way, this session will actually allow you, even though you may be a beginner, you'll allow you to at least understand the concepts behind winterizing an irrigation system. Just to let you know, we are allowing questions. If you don't mind, because we are online, if you don't mind holding those questions off until we complete. It's not a very long session, but once we're done the session, we'll host those questions, or if you want to type them into the chat, we can always review them at the end of the session. I will be glad to do so. Just so we don't, fragment the whole procedure or the process of instruction. All right, so we'll get started. I think Kathy's going to keep an eye on anybody else who is late to join, but that'll be fine. I'll get started now. So winterizing an irrigation system. Welcome everybody, and let's continue on. So in today's session, what we will discuss is the 10 steps, 10 easy steps actually, of how we complete a winterization on an irrigation system for either a commercial property. A lot of times we have clients that are larger buildings and they have irrigation systems, or even a residential system. So it's a very simple process, but there are steps that you need to follow for safety, as well as for obviously the process of making sure that we empty out all the water from an irrigation system so that we don't have any bad things occur over the winter. So yes, specific to residential and commercial system. And then we will touch on winterizing drip line. So if any of you have had any experience with drip line, I will show you how to properly winterize a drip zone. Drip line is tubing, in case of those people who don't know what drip line is. It's a tubing that has small holes or emitters that allow water to basically drain from it, but with a very slow rate. It's a slow volume method of irrigating. And so you see all these long tubes of wrapping around shrubs and plants and trees that allow water to basically irrigate right at the root of those plants and trees. Okay, let's continue on. Why do we winterize? Well, it's actually rare nowadays to find an automatic irrigation system in our climate that the owner does not prepare for the coming cold temperatures. We do have significant freezing temperatures in our region, and irrigation systems will not necessarily survive these cold temperatures unless we do empty them of all the components in the piping, of all the water that gets trapped inside of them. As we are aware, water will expand when it freezes. And when it expands, whether it's sitting inside a piece of plastic or in metal piping, it can crack, split, break components once it sits in there and once it freezes as water expands. So it is imperative that we do make sure that we empty out the water of an irrigation system. To properly maintain an irrigation system, we will drain these components of water before it has a chance to freeze and cause damage. This is a picture I'll show you quickly of a split piece of copper. And this happens, I mean, I won't say regularly, but this is very typical of a line that was allowed to, that had water in it, and it was allowed to freeze basically in cold temperatures. And so if it's just a couple of hours that the temperature drops below zero, it may not do that kind of damage. But certainly once it gets into, a couple of days of minus temperatures, this is very typical of what water will do to copper pipe. So you can imagine now, here's why, again, we have in many cases we use PVC. This is a PVC pipe. And you can see just based on this picture what happens to a piece of plastic. And this is fairly hard plastic. But once water freezes in there, it has no place to expand to but out. And so what it does, it actually splits in what they call a herringbone pattern. You can see it splits along the pipe rather than across it. The PVC fitting that is sitting there, that PVC-T, it just absolutely shattered apart. I mean, this is very, very typical. So polypipe, which is what gets used a lot in irrigation, that's the black plastic polyethylene pipe. It's a little bit more forgiving because it does have a little bit more flexibility to it. But over time, even polypipe in the winter will split. If it freezes or if you have water in it and you allow it to freeze, it will split the polypipe as well. And over time, it becomes a lot more brittle. Polypipe, the older it gets a little bit more brittle. So it almost becomes and acts and behaves like PVC after a given amount of time. So it's imperative that we do maintain irrigation systems. I've been doing irrigation now, like I said, it's almost 29 years I've been doing this, and looking after the clients that I look after, I make sure that every winter we go by and make sure if they've been using the irrigation system during the summer months, that we have to drain that system completely of water. Here's a couple of other pictures that you might be able to see. Now, this is a brass. I mean, if you can see this, this is what they call it's a backflow prevention device, but it has these check valves on either side or ball valves on either side, and they're completely split open. And you can see the type of split along the ridge of this brass check valve or ball valve, sorry. And to say the amount of pressure that must be, if you can imagine, this is being split by water, just by freezing. The amount of pressure that it would take to split a piece of brass is incredible. So you know that freezing water has some significant power that's being associated behind it. So don't assume that, it's not going to do anything to your system. It will. Damage caused by water freezing in an irrigation system can be extremely costly to repair. Believe me when I tell you that it does. And sometimes those repairs are worth many times the cost of a professional fall shutdown. So, meaning to say, for what it's worth, we charge, obviously, it's a service charge. It's a chargeable service to come and winterize somebody's irrigation system. And depending on the size of the system, the prices may vary. But believe me when I say that, I've seen some people say, "Oh, I don't bother with winterizing my irrigation system. It's fine every year. I have no problem." Some people are lucky. They may get away with not winterizing their system, and I've never understood that, because 99.9% of the systems that I see out there, if you leave water in them next spring, you're gonna find a lot of damage. And so it's always a good idea to make sure that we professionally winterize it. It only takes a few days of minus temperatures to start bursting pipes or damage components. So don't delay in getting your systems properly winterized. Absolutely. If you're dealing with your own system, that's one thing. But if you have clients that you're looking after, and they're relying upon you to winterize or look after the irrigation system, this is going to be one of those steps that you will not want to miss. Let's put it that way, in the servicing of that irrigation system. So let's begin. So step one, we need to make sure that when we go to winterize an irrigation system, that the water supply line is actually closed. If we don't close it, we are not going to be able to winterize that system. And that water shutoff, and this is just a picture of one, they're not all typically, they don't all look like this, but this is a ball valve situation. And you can see in a ball valve, when it's in line with the actual valve, that means it's open. When it's perpendicular to that valve, that means it's closed. Keep in mind, this is only one type of shutoff valve. So you will see sometimes on the city or municipal shutoff valves, sometimes they're what they call curb stops, where you actually have to have the municipality come and close it. or they have these large, long keys that slide into a pipe in the ground, usually about 4 feet down, and they actually have to come and close that water supply system. Ball valves. I'm just going to give you a quick cross section of what a ball valve looks like here because it's fundamental that you understand how they operate. So point A is the stem off the handle on that ball valve, and point B is the actual ball. And so if this is a cross section of it, this is an open ball valve, so water will be able to travel from one side all the way through to the other side. Once it closes, which is usually a 90-degree turn, the opening of the ball actually sits sideways in the valve, and so no water can get through that little opening here. And so now you've actually closed that ball valve. There's another type of valve, which is called a gate valve. And a gate valve is one where the actual threading of that valve will either wind up or wind down this little circular gate. And so water will travel usually. So A is the stem that moves around. B is the closing portion of this valve. So it's basically it closes by not allowing water to travel through, where you can see this circular hole there that would normally be the actual way the water comes through. Once you close it, you will be cranking this handle clockwise to close it. Anti-clockwise will be opening it. So then water will be allowed to flow through. Both of these valves are very typical in irrigation systems, and you will find either one or the other being used as a means of shutting off the water supply to an irrigation system. I have found, and this is where experience has come into this, these gate valves, over time, they have these little seals, and these seals over time can wear out. Even though you may think that you've closed this gate valve completely, sometimes because these seals are worn out, water is actually allowed to trickle through to the other side. So please be aware that when you see these gate valves, the majority of the time they work fine. Sometimes you will say, well, I closed the gate valve, but water was still dribbling through to the irrigation main line. I'm not quite sure why. Usually it's because the seals on these have failed. So be aware of that. The seals can fail on a ball valve too, but not as prevalent as I've seen on gate valves. So just keep that in mind. Pumps. So pumps on an irrigation system do occur on occasion. Sometimes they're what they call a jet pump or centrifugal pump. These are two types of pumps. This is a submersible pump. This is a centrifugal pump. So that basically on a pump system, you want to make sure that if they are exposed to the elements, that number one, they get removed from the exposure to those elements. So removing pumps and disconnecting pumps from an irrigation system, pulling them out of the water source that, let's say, for example, if you've got this submersible pump that actually sits in the body of water, it actually has to be removed so that it doesn't get damaged. There are impellers and so forth within these pumps that can possibly get damaged over the winter as well. So they actually have to be removed and placed in and stored in an area where it's obviously warmer and drier so that it doesn't have any damage occur to it throughout the winter months. So we make sure and remove pumps from irrigation systems if that system does have them. So you have to know how to disconnect pumps. Be aware, let me just go back to that slide there. Some of these pumps have electrical supplies that go to them that are significant. Some of them are 220 volts, some of them are 110 volts. So just be aware when you're disconnecting these pumps that they're electrical as well as mechanical, meaning the piping that usually gets connected into them, that you would have to disconnect. So just be aware of how to do that. This isn't the session that we start dealing with pumps, but just to be aware that if you do have an irrigation system with pumps on them, that they do need to be disconnected. What other devices that must be removed prior to winterization? Well, in some of these irrigation systems, especially in some larger commercial or municipal applications, we have these flow sensors. And so what these flow sensors do is they measure how much water is actually being utilized in an irrigation system. So as the water flows through it, there's an impeller there, or there's a little turbine that turns, and it measures the flow of water. So you can tell, or the municipality can tell, exactly how many gallons or liters are being used in the irrigation system throughout a day or throughout a season. And the information is reported back to them with this wire. It's connected to a device that on the controller can measure how many gallons per minute or how many gallons per day has been used for irrigation purposes. They're different sizes because they actually do sit on the main water supply line of an irrigation system. So because different size irrigation systems will have different main line sizes, they actually have these type of flow sensors to accommodate the different size diameter pipes. And you can see some of them get really, really large. And so these flow sensors, again, because of the device that's sitting within the cap here, if we don't take them out before we winterize, and I'll explain to you what happens when we do winterize, because we're using compressed air to winterize, we can damage the little calibration that these sensors have for the next season. So let's say, for example, if we use compressed air and we start blowing air through these devices, the little paddle wheel or the calibration on these paddle wheels gets thrown off. So now they're no longer reading correctly. So we want to make sure that we don't damage them. So usually what ends up happening is, as you can see, there's a type of pin that's holding this in place. We'll pull out that pin, remove this whole top portion where the wires are coming out of it, and put in place just a plug. And so that we can now winterize this without damaging the electronic component of this flow sensor. So yeah, we don't want to blow compressed air through any of these flow sensors because that will damage the calibration. Now, typically, as you can see in this picture here, when I do winterizations, when a lot of companies, irrigation companies are doing winterizations, they're doing so with the use of a tow-behind compressor. And this picture here shows you a typical truck with a tow-behind compressor that is being used to winterize an irrigation system. This compressor is nothing more than it's an engine, it's a motor. And so what it does, once it starts building up pressure, air pressure in a pressure tank, and then it allows it to blow air through hoses that forces water out of irrigation systems. These compressors all have volumes that they're capable of producing. And the air is set at lower operating pressures than most because our irrigation systems cannot handle high pressure compressors. There are some compressors that are set for very high pressures. We want to make sure that our compressor, so not to damage any components in an irrigation system, we set them at a lower pressure. And that usually typically will run from around 75 to 90 psi. These compressors are measured in CFM, which is cubic feet per minute. What they're talking about is volume of air. So this one here, pictured, is what they call a 185, and that just means it's got 185 cubic feet per minute of compressed air blowing through it. So again, it's the volume of air as well as the pressure that's set on these compressors that we're using to winterize irrigation systems. There are long hoses that get attached to these, and then these hoses get attached to an irrigation system to be able to blow out that system, what we call doing blowouts. It's a I guess a terminology that we've done and used for many years. We call it a blowout or winterizing an irrigation system. For larger main lines and piping on larger systems, an air compressor of 250 CFM may be required. So the larger your irrigation system piping, you may require a higher volume of air to be used at 75 to 90 psi in order for you to get all of that water out of that system. So understanding volumes is important. The 185, to be honest with you, will blow out. So let's give an example. I can blow main lines out of inch and a half in diameter and smaller with a 185, no problem. I can actually use it for a 2-inch main line, but it sometimes, depending on the size of the zones, and we'll talk about that in a minute, depending on how many sprinkler heads you have on a zone, when you get into a 2-inch main with larger zones, you may decide that it may be beneficial for us to step up the size of that compressor to a 250 CFM. A lot of these compressors, some of the irrigation companies that are out there, they own their own compressor, but a lot of irrigation companies actually at this time of year they're rentals. And so we go to a rental company like, whoever you use, like Cooper Rental or whoever it might be, for your rental, and you can actually pick up these compressors. They just hook up to a back of a truck or a van, and you can tow them around and use them for winterizing. Usually at this time of year, we rent ours and we keep them for at least a month, sometimes 2 months, depending on how many customers you have to winterize. Golf courses. I'm not going to deal too much with golf courses, but golf courses, they have even larger units because they may even use multiple compressors on their system because they actually empty large pipes, really big pipes. We're talking sometimes 6-inch diameter pipes, 8-inch, 10-inch, 12-inch diameter pipes. So they get into some really large pipes. And so they sometimes will have multiple larger units to winterize those systems. You can see something like this will be very typical for a large golf course. It's a 1,300 horsepower. That's quite huge. If you are renting an air compressor, I would recommend book it now. At this time of year, we have a lot of people in the irrigation world that are renting. And so what ends up happening is air compressors are flying off the shelf, if you want to call it, and a lot of these rental companies. So if you're going to be doing irrigation winterizations with a compressor that you need to rent, book it now. Yeah, this busy time of year for rental companies, don't miss out. Absolutely. And don't forget your hoses. That's very important. So a lot of these compressors in this picture, you see this is a larger hose, but a lot of these rentals, they come with hoses attached to them. And so if you don't have your own, it's not just a garden hose you can use. These are actually thick pipes or thick hoses that are designed for the use of these compressors, and they can withstand higher pressures. And they, typically look like this. You can get, a 1-inch. They're very typically on the ones that we use. We have a 1-inch, and they're almost like a rubberized material. And they have, these very tight clamps that hold these connecting fittings together on them. And they just basically will, you can get them in 50-foot lengths or 100-foot lengths, and you can, connect them together for longer runs of requirement of hose if you have distant connection points from where your compressor is. Now, I'm going to put this as a caution here. Due to the amount of pressure that these compressors work at, make sure proper operational training and safety measures are practiced by all staff and people. If you are using these compressors, make sure you get proper education on how to use them. They can cause significant damage and harm to somebody if you don't know how to use them, especially with compressed air. And to that point, take a look. If you are renting hoses, make sure these hoses are in good condition. There's no damage, there's no splits. Because if you see a hose that blows apart, I've seen it happen, a hose that blows apart while being used by an air compressor, it will start flying around like you can imagine something on high pressure. It will start flying around until you shut that compressor down. So, and you don't want to get hit with any of those brass or metal buckles at the end or these connectors at the end. One of these things hit you and it can do some significant damage or if not kill somebody. So make sure you get proper training. Step number 3, let's connect our compressor. So here you can see this yellow hose that's coming into this water line here is connected to, and this is just a hose bib. So we actually have fittings that will go from this hose to a hose bib fitting, and we thread that fitting onto the hose bib, which will now allow us to blow compressed air into our main water supply line. So this is what we do. It can be a hose bib. It's not always a hose bib, but that is one blowout port, we call it. This is a connection point to where we are having our compressor hose attached to the irrigation system. Other types of blowout ports can be and some people call it a quick coupler, sorry, or a turf valve. You'll see these on parks and rec, golf courses use them. So these are just valves that are sitting in the ground. They have this brass key that fits into the valve and allows you now to open that valve and blow compressed air into the line or piping of that irrigation system. So this is just another type of blowout port. Prior to opening the valve on the air compressor side, ensure the following. So this is now you've got your piping hooked up, let's say from the compressor to the blowout port. Let's just make sure a couple of things are occurred before you open the compressed air into that line. Open an escape route on the irrigation system. So usually means that allow water to be blown out from another end of that system. Either a valve, so the zone valve can be opened, or a quick coupler if they have them on that irrigation system somewhere else on the main line. You can open that quick coupler as well. The reason being is that we don't want the main line to become overcharged with compressed air. Air, not like water, is very compressible. And if you allow the air compressor to charge up a main line without the ability to have it expel air through an opening somewhere, the main line can burst. The mainline pipe can burst because it may reach the pressure rating that surpasses what they call burst ratings can handle. So this could cause a mainline blowout, which will now damage your main line, which means now that you can't winterize that irrigation system if you blow it up. So don't keep it running for a long period of time, charging up a main line. So the whole idea is until you're ready to actually winterize it, don't open the valve of the compressor until you're ready to actually winterize. The other reason is when sprinklers are cold, and at the time of year that we're doing these winterizations, so typically starting, I'm actually starting my company's winterizations, we start Monday, believe it or not, end of September, and all throughout October and sometimes into middle of November. Some people are still blowing out. I try not to get that far into the season because in November we have had and you can have significantly cold days. And if they get below freezing for a few days, now all of a sudden the water in those pipes will start freezing. Now you can't blow it out until you warm up those pipes to the point where air can travel through. Because if it's frozen, no air can blow through that. So anyway, the other reason that we try and not charge up the main line with such high pressure is cold sprinklers, and because they're made of plastic, the plastic suddenly gets very hard because of the temperatures. Suddenly opening a valve, which has very compressed air on it, can blow sprinkler heads or clean off the pipe. It can literally crack those fittings that hold it together, and the sprinkler head just goes flying up in the air. I've had it happen to me, so I know it does occur. And sometimes, depending on where you are, it can cause injury or damage to property. So, and this is just a picture of air. Literally, a sprinkler head just flew off of this pipe, or maybe it was broken off. I'm not sure, but you can see the rush of air and water blowing out of that hole. It can be significant. So just be careful of that. Just be aware of it. Step number 4, the irrigation system can be automatically run from the controller with the water off and the air compressor on. Or each valve can be manually opened so you know each zone is clear of any water. So in order to actually winterize an irrigation system, we actually have to go step by step. So through every single zone that is connected to that irrigation system has to be blown out with compressed air. You can run that controller, so meaning to say you can go to the actual controls of that irrigation system and turn on zones 1 through whatever it is, or you can actually manually go to where the valves are in the ground and open each valve manually. And I'll teach you a little bit about how to do that. Remember, if you are running the system automatically from the controller, some of these controllers have, or many of them do, have sensors on them, whether it be a rain sensor or a soil moisture sensor. And depending on the time of year, we could get damp days. If there's a rain sensor on that controller and you're trying to winterize, it's quite possible that that rain sensor is going to prevent you from actually opening a valve. So make sure that the sensors have been either disabled or bypassed so that they don't disturb you running that controller to winterize that irrigation system. And that's just a typical rain sensor. Another rain sensor, that's the type of flow, sorry, it's a soil moisture sensor. And so these sensors can prevent the system from running because they're there to do, these devices are there to measure if there's been rainfall, like say, for example, over last night, we had a lot of rain. If there was rain on there, these rain sensors are now deactivating the controller from running. So you want to make sure and bypass. There's usually a switch on your control that allows you, or even on some of these rain sensors, you can bypass the rain sensor to allow your system to run. So if you are running it from the controller, remember these little sensors can have a significant impact on whether or not they run. If you're running the zones manually from the valve, there are two ways of opening the valve. Number one is by turning the solenoid. And if you look at these valves, this black cylindrical device on top of the valve is the solenoid. And if you were to crank that anti-clockwise, usually it's a quarter turn. Some of them you may have to turn a little bit further. But if you open that solenoid, you are in fact opening this valve, the electronic valve that holds back the air or water, now is opening the valve and allowing it to flow through into the zone, the lateral line to the sprinkler heads or the sprinkler emitters. So by opening this valve manually, you are allowing compressed air to flow through it. The second way, and if I can show you just on the top of these valves, they have a little tiny, this bleed screw. Many of these valves have a little bleeder screw. If you were to open that, and sometimes just with a screwdriver, you just crank that open, you will allow the valve actually to operate as well. And you can do so either way, either through the bleed screw or cranking the solenoid open quarter turn or half turn. So there's another way of opening a valve. You don't have to run it from the controller. You can run it from the valves, which a lot of irrigation technicians do. We go through and we find it easier just to find the valve boxes and open up each valve and continually run through opening and closing valves throughout the irrigation system to winterize it. You must know, if you are using the manual approach, you must know where all these valves are. In some instances, you may not. So it's recommended that you run it from the controller if you don't know where all the valve boxes are, because sometimes they get covered, especially at this time of year, leaves start falling. Next thing you know, you can't find these valve boxes because they're covered in leaves. So the whole idea would be to make sure that you winterize from the controller if you don't know where they are. It's very important. Typical controller, and you can go through and start it up, zone number 1, zone number 2, zone number 3, zone number 4, etc. You can keep going through zone by zone by zone by zone. Once you're done, the controllers can now be put to bed. So because they're not going to get used until next spring. If the timer is indoors, meaning to say it's in a warm environment, you can simply unplug them to conserve power. You don't have to. You can keep them plugged in if you want. Many of our clients that we service leave them plugged in. Some of them decide, oh no, I'm just going to unplug it. And you can unplug it. It's not a big deal. Leaving them plugged in, obviously, it keeps the time, it keeps the programming, it keeps all the scheduled selections available by leaving it plugged in and just turn it to the off position. It doesn't allow the system to run, obviously, because you've shut the water off. but it's allowing obviously the system to stay scheduled, and it allows the system to keep the programming information in there. If you unplug it, many times you're going to lose that information. So we won't be able to do anything with that next year until we reschedule and reprogram that controller. Outdoor controllers would be better turned off but left plugged in, and I'll explain why. A lot of the outdoor controllers have there's a small transformer in them, and the electrical transformer can generate enough heat to keep a lot of the electrical components inside the internal guts of that controller. It keeps it slightly heated so that a lot of moisture and damage caused by that moisture is kept away. So a lot of times with external controllers, I would recommend just leaving them plugged in if you have an outdoor controller. Let's do step 5 here. And if you guys, again, as we're going through this, if you have any questions that may come up, let's just conserve them till the end, and we'll make sure and go through that. Ensure all the water is discharged. So zone by zone, we are going to go through each zone and make sure now, as the compressor is turned on, the air is flowing through the system, and we're going to go through each sprinkler zone to winterize. Once you see the surging of the water, so as you first open a valve, you'll see water start squirting out of the sprinkler head or sprinkler spray, and you'll see all of a sudden now, as the water is diminished, it'll start creating what they call misting. And so you'll see this mist coming out of it. And so what you want to do is you want to ensure that you get into it's usually a few minutes before you properly winterize a zone. You want to make sure that a lot of the water is dispelled from the main line as well as what they call the lateral line. So the main line leads up to the valve, lateral line is beyond the valve, and that leads to the sprinkler heads. So we want to make sure that all these sprinkler heads are properly winterized. It can take a few minutes, depending on how much water is in the main line or how large the system is. So keep an eye on that misting. Once you see that misting start to diminish, and you see that it's starting to go away, then that zone is pretty well winterized. Sometimes some contractors may do, a few minutes initially through all of the zones and then go back again and run those zones for a few minutes again, just to make sure that if any water tends to, as it's blowing through piping, it tends to push up to the side of the pipe. And then as you shut the zone down, it actually falls back down into the bottom of the pipe. So recapturing some of that water that falls back down is what they do. And you can see this is just a picture of a system being winterized. It creates that mist. It's just water vapor, water droplets that are being expelled from the sprinkler emitter or sprinkler head, and you'll see that it will diminish after some time. Step 6. Sometimes we may decide to preserve the life of rain sensors. So this little cap device here, you can actually remove the cap portion of it, which holds it's cork-like material that's inside of this cap that is causing the rain sensor to operate. The more it gets through a winter season, let's say, for example, ice and water, and it could damage those little cork rings that are in there. So a lot of times people decide to remove those caps of a rain sensor and store them somewhere dry and warm. You can do so. Some may loosen the cap to its largest setting just so it doesn't keep pressurizing when it gets wet. And it just helps some of the conserving of the cork material. Just make sure that if you do remove it, that you put it somewhere safe, that you don't forget where you put it. And so because in the springtime, you're going to want to put it back in before you start that system up. Step 7, at this time of year, you may notice as you're doing winterizations, you may notice that there are some irrigation systems that require repairs. Typically, for breaks or damage that would either allow water to seep back into the irrigation system or B, prevent the air compressor from pressurizing the irrigation system enough to be able to expel all the water that's accumulated in the components, we will not necessarily do repairs. If it means that it's going to prevent us from winterizing, then those are the repairs that kind of have to be done. If you cannot winterize the system properly due to a pipe break or due to something that is not allowing the system to be pressurized, then those are the repairs that I would be doing. I certainly won't necessarily be doing repairs to, sometimes there are sprinkler heads that could be cracked or damaged, missing a nozzle. I won't be doing those types of repairs necessarily until the spring. So you don't have to equip yourself to be doing them. Some people choose to do them, but it's not necessary. Step 8, wiring and tagging. So this is actually it's a good practice to get into to ensure that the system remains closed. So the water shutoff, you want to make sure that that stays shut throughout the whole winter during the winter months. Some people will either wire tie or zip tie the shutoff handle in the closed position. And this provides additional safety for the water shutoff not to be tampered with or accidentally. It's happened numerous times. I've seen it happen. It accidentally gets turned on. Somebody thought they were turning off something, and they end up turning the water back onto the irrigation system, filling up the main line again. To clearly identify the shutoff handle, it's a good idea. We use this a lot. We put these tags around the shutoff handle, and it can be wired around the shutoff just to show where the irrigation supply line is. Our tags have our company name on it, and it says irrigation shutoff valve. Please do not touch kind of thing, and with your contact number and so forth. You can put dates of winterization that you've completed on it. Some people decide to write winterized on such a date, just so that people know when they were winterized. And you just wrap this around the shutoff handle that supplies the water to the irrigation system, just to make sure it stays closed. In some steps, on step 9, we may need to disconnect our main water supply away from the hose bib. Some homeowners use their hose bibs, they want to use their hose bibs beyond the winterization of that irrigation system. So in that case, we actually have to disconnect the main line, plug it so no water can enter the piping of the system, and then reconnect that hose bib so that the homeowner or a client can use that hose bib again. So that is step 9. If your irrigation system is connected to a frost-free hose bib, this valve must remain closed throughout the winter months, so not to allow any water to re-enter the irrigation system. And a frost-free hose bib is very typical like this. It looks a lot like this, and I'm sure some of you may have seen it. What these things do is basically it's a long stem shutoff. So from the outside, you don't actually have to shut water off from inside at all. The shutoff is right here where it says valve. That is where, and it's usually in the warm environment, so that's where it's holding water back. Any water that gets trapped in there, it gets siphoned off, this anti-siphon valve. So it gets siphoned off, and it basically allows water to drain out automatically. Because it's inside of a warm house or warm building, we don't need to necessarily have water shut off beyond this. We can just close this off and it's done. However, if the homeowner again decides that, oh, I need to use my garden hose to wash down something, if they open up that valve, they will let water re-enter the irrigation piping unless you've removed that piping away from this frost-free hose bib and you've disconnected it. So just make sure if anybody is using water beyond your irrigation winterization, that you disconnect your main line and main water supply feed away from that source. Step 10, drain valve. So in some instances, it's a kind of a dark picture, but you can see this gate valve here is the main water supply to the irrigation system that goes out the wall. There is a drain valve, which is nothing more than a hose bib that allows the system to drain itself beyond closing this gate valve. So if water is traveling down and then out, after shutting this off, by leaving this open, if any condensation should occur, or if this gate valve should allow water to seep through it because of the fact that the seals are damaged and water is dripping through there, rather than that water being allowed to drip into the irrigation system, we leave this open so it just drains onto, I mean, usually this is in a mechanical room area, and we have it just drip onto the floor. If any condensation should occur, or if any dripping should occur through the seals of this gate valve, then it has an escape route before filling up our main line. So this just allows to keep water away from our main line during winter. I just want to quickly go through winterizing a drip system. So it's very typical. I mean, a drip zone will be attached to an irrigation system in the same way sprinkler heads and rotors, any other emitters are attached to an irrigation system. However, the drip systems are designed typically with low pressure. So there's usually a pressure reducer on a drip line system. Allowing the drip system to be open manually while other zones are running. So not to apply too much pressure is a good idea. So usually what will happen is I will go through and I'll open, let's say, for example, a valve to a spray zone, for example. While that is running, the blowing out air through that spray zone, I may go and open the drip valve as well. That just means less pressure is being applied to that drip piping. The reason being is that drip line, most of the fittings that apply to drip piping are just, they're pressure fittings. They're not held and clamped in any way, shape, or form. If you put too much pressure through a drip zone, you can blow fittings apart. So that was one of the reasons. The other reason it's not going to provide, because of you can see this little dribble of water that's coming out of this emitter. That's typically the fastest that you're going to get water to come out of these drip pipes. So in order for you to actually winterize these properly, typically they will have what they call release valves attached to drip zones. So what will happen is that you can open up a release valve at the end of the lines of these drip zones or drip pipes, or sometimes these, what they call these figure eight, gets attached. It's basically the water comes here and the pipe is crimped, and so no water can get past it. We remove these figure eights and open up this bend in the pipe to allow excess water to be blown out of the zone. It just means that you're going to winterize these zones quicker. Typically, because of these holes, it's very rare that drip line will retain much water beyond winterization. It's very rare because these holes will always allow water to, if there's any pressure, it'll allow water to drain out of it. So a lot of times, you can blow out drip zones very quickly. Once water has been released from the drip lines, ensure that the drip valve is closed again and then retie the end. So if there's a figure eight on the end of it, or it's crimped over, or it's, some people wrap it with electrical tape. I've seen it. Don't forget to reapply this, because if you forget to do this, come spring, when you open up the zone, all this water will be overwatering. And if you forget, it's not going to allow this drip zone to operate properly. Winterizing backflow prevention devices. So a lot of irrigation systems here in Ontario, we have backflow preventers on them. And these are devices that are basically check valves that allow water to go through it, but not come back into potable water. It's just a protection. So any, let's call it contaminated water, does not allow it re-enter your potable water. So these are typical backflow prevention devices. There's all sorts of different ones that we use here, depending on your plumbing code for the region that you are living in or working within. You may see all these different types of devices, and these different types of devices are based on the use of an irrigation system and what type of water is being protected. If you are winterizing an irrigation system that requires blowing through a backflow prevention device, you need to find out whether or not that manufacturer allows compressed air to be blown through that backflow prevention device. Not all of them can withstand compressed air being blown through them. So you have to find out, first of all, can this backflow preventer allow compressed air to be blown through it? If not, then we have to make sure and remove that backflow preventer before we winterize that irrigation system. If you can blow compressed air through it, there are these little, what they call test ports. All these test ports can accumulate water. They're tiny little, and if you can see this picture here, it has a little slotted screwdriver kind of valve that you can open and close. So what you want to make sure is as you're blowing air through it, that you open these test ports to allow any water to get trapped in there to get released. So these test ports get winterized as well. So just to make sure. There are these little ball valves on either side of this backflow prevention device. And again, once you have winterized, we would typically close them. But I'll show you how to close these ball valves after we've winterized. So yeah, once again, if you can't blow through an irrigation backflow prevention device, you have to remove them, blow through the connecting pipe, and cap it once this is complete. So you have to remove the backflow prevention device, store it somewhere again, warm and dry, and then blow through the piping, the connecting piping, and then cap that once done. Winterizing a backflow prevention device, once you have finished winterizing, we would typically not close these all the way. Unless this is the device that is actually holding water back. If this is the only shutoff that's holding water back, then this must be closed, but that's usually typically in a warm environment. If for whatever reason it's not, obviously there should be a separate shutoff that shuts the water off before this backflow prevention device. After we've winterized, we leave these ball valves at a 45 degree. The reason we do that is in these ball valves, you can imagine any condensation that gets trapped between the ball and the brass outer casing of this valve can sit there in the winter. And if that condensation is allowed to freeze, it can split that brass outer casing. So what we do is we leave it at a 45 degree. If any condensation has to get moved, it has room to travel if you leave it at a 45 degree angle. Final note, you should have a good understanding of how to winterize an irrigation system. There are lots of different styles of systems out there, and some have multiple water sources. So please understand what you're about to winterize. Keep an eye on the compressor, learn compressor safety use, and how to disconnect your hose after you've done the compressor, done using the compressor. You don't just unhook the compressor hose because that thing is full of air pressure. That thing will blow off and hit you in the head if you're not careful. I've seen it happen. So you have to release the air compressor, release the pressure of the air that's on it after you shut it down, and make sure that you disconnect the hose after you've released pressure. On behalf of Landscape Ontario, I thank you for your participation. I will now, and listen, have a great winter season. I would like to open up the floor to questions. If we've got some questions, we've got some minutes here before we finish.
Yeah.
Thank you, Kathy.
Good information. Yeah, you guys, you can just unmute yourselves if you wanted, as opposed to typing in if you just want to fire off a question.
Yeah, I don't know if there was, I wasn't keeping an eye on the chat, Kathy. Was there any questions that
I
were?
don't believe there's anything in the chat, but yeah, Brandon, did you have something?
Yeah, Steve, with our system, we're pulling from a creek, and the first bib we have, hose connection bib, is about 100 meters. And then we have other ones down the line, and then the zones going into the gardens. When we're blowing out the line, should the valves closest to the water source be open first, or do we start at the end of the line when we do a blowout?
So I would recommend, so there's two things here. The way I typically do it, I would start with the valves closest to the water source. However, it's always a good idea to go to the furthest valve and open that one as well. So what you're doing, typically a compressor can handle two valves being open at the same time. If not, then what I would do is go to your furthest valve and winterize from there first. And then, because what will happen is that you will empty out the majority of your main line through that furthest valve, and that'll take a while. So what will happen is that then you can actually go back and start from the first or closest valve and then start winterizing that way. It's a good practice to make sure that you go from start to finish blowing in the direction of the end, right? So you want to make sure that you want to capture all that water. But I typically will try and go to the furthest valve, release as much water as I can through there, and then start from the first valve.
Okay. In our case, our furthest zones, the last three zones are that spaghetti tubing for the pots. So is that too much pressure for those little guys to handle?
And it may be you might want to open the three of them at the same time. If it's all that is running, you may want to open those three at the same time and allow the water to drain as much as you can through there, and then start again. I would still start again from the beginning and go through until you reach again those three zones again, and then winterize it again that way. It's going to take you some time because it's a big system, right?
And one other question I have, some of our solenoids are very tight. Is there any way to loosen them off?
When
Like
you say that, when you
they're
say
very,
they're very tight, it means you
well,
can't grip
I
them,
mean,
you can't turn them by
they're
hand.
manual. For one, they're manual, so I have to shut them on and off manually, but they're very tight to turn.
It shouldn't be that tight. Those solenoid valves don't, and the solenoids don't need to be that tight
Right.
on a valve. I mean, if you have to use channel locks to open them up, that's
No, I'm
actually,
talking probably about 15 pounds of pressure to turn them. Is
yeah.
there, do they need to be replaced or should they be?
Hard to tell you at this point, but yeah, they shouldn't be cranked down that tight. To close those solenoid valves, they shouldn't be cranked too tight. You should be able to use three fingers to close a solenoid, and that's it.
Yeah.
And that's all it is.
Okay.
If you have to grip it that hard to open it, though, I mean, yeah, that usually means they've been cranked down significantly, and it may be time to replace them. I'm
Yeah.
not
Okay.
sure.
Okay. That's it. Thank you.
Thanks, Brennan.
No worries, Brandon.
Any
Thank
other
you.
questions before we say goodbye for today? Okay. Well, thank you, Steve.